Hi, this is the third video to the Chapter 3 review, project number 4. Let's remember for number 5 our average rate of change formula. This is the same formula as slope, and in this case the b and the a are our x values, and in this case one of them is -2, one of them is 3. It doesn't matter which is which, but we'll call -2a and B3. We are going to plug this in. Now, in order to do this, we have to figure out what f of 3 is and what f of -2 is. So over here on the side, let's go ahead and figure out what these two values are. So let's go ahead and solve these. So pause the video if you need, but I have the f of 3 equals 0 and the f of -2 equals -20. From here, I'm going to go ahead and plug these into my function. So the f of 3 is 0 minus the f of -2 is -20. And so it looks like our average rate of change is 4. Let's jump to our piecewise function. When x is less than or equal to 1, we're going to use this top part of our function, but when x is greater than 1, we're going to use this bottom part of our function. Let's first graph the very top here. Now x has to be less than or equal to 1 here. One thing you can do is create yourself a table. And I am going to plug in values in my table that are less than or equal to 1, just a few of them. Now notice I used x equals 1 as well. I'm going to put a closed circle there just to remind me that x is allowed to equal 1, okay? From here, let's go ahead and figure out what our y values would be. And looking at the table, I'll have a closed circle at 1, 3, another point at 0, 4, another point at -1, 3. I also know this is a parabola because of the x squared, and he's facing downward because of the negative. So please notice I plotted these points, and since this function continues when x is less than or equal to 1, I'm going to keep having a downward parabola. And this is just a rough sketch here. In the color blue, let's go ahead and make a table for our second function, our 2 minus 2x. Now notice x has to be greater than 1. I'm still going to put 1 here, but I'm going to tell myself I need an open circle there because x is not allowed to equal 1, but it can be infinitely close to 1. Let's go ahead and plug 1, 2, 3 in for x and find out why. And here are our points. Looking at this graph here, we know that 2 minus 2x, that's a linear function. It will be a straight line. So that will help guide us just a little bit as we plot our points. Remember, we are going to have an open circle at 1, 0. So I'm going to put an open circle there, and then 2, -2, and 3, -4. And this continues onward. So there is our piecewise function. For the domain, our domain exists everywhere from -infinity to infinity. Our range is a little bit different. Our range are the y values. So let's notice here that the largest y value we possibly have is a 4, and then it goes down infinitely. So therefore our range for this problem goes down infinitely, -infinity, and its very maximum value is 4, including 4. If we take a look at number 7 and we graph this on our calculator, we will end up getting a graph that looks maybe something like this. We'll learn that since the leading exponent of the degree is a 4, this is going to be its end behavior here. So there is no absolute maximum for this problem. However, there is a min, and if we calculate this on the calculator like we did in class, we will approximately get a minimum at about x equals 3-ish. It's more like 2.9, but just around this, let's round that to negative 22 here. Okay, and then where is this function decreasing? It would be decreasing from negative infinity all the way until 3 here. And it would be increasing from 3, x is 3, all the way to positive infinity. Okay, and that concludes part 3 of this video. I'll see you in part 4.